Solve exponential and logarithmic equations. Property of equality. For exponential equations. If b is a positive number, other than 1, then b to the x is equal to b to the y, if and only if x is equal to y. So if we had 4 to the x is equal to 4 to the 7th, then that means that x is equal to 7. The property of equality for logarithmic functions, or equations, I guess. If b, x, and y are positive numbers, with b not equal to 1, then log base b of x is equal to log base b of y, if and only if x is equal to y. So if I have log base 2 of x is equal to log base 2 of 7, that means that x is equal to 7.
I remember like the beginning of this math year, I got like 106 on a math quiz, and like I thought, oh, math's not gonna be bad this year. Well, how the things have turned.
Alright, solve the equation.
Like, can you scroll up a little bit, please?
7 to the 3x plus 4 is equal to 49 to the 2x plus 1. So for me to be able to use this property of equality for my exponential equations, the base has to be the same. So I have a base of 7 over here and a base of 49 here. Is one of these able to be rewritten as the like a power of the other one?
Yeah.
Which one?
49.
Yep, so I can write this as 7 squared. So over here I have 7 to the 3x plus 4 is equal to 7 squared times 2x plus 1. So we multiply the exponents when we write it that way. So then now I can take and just say 3x plus 4 is equal to, I'm going to go ahead and distribute this 2 here. So 4x plus 2. Subtract 3x, subtract 2. So I get x is equal to 2.
All good now.
6. 27 to the 4x minus 1 is equal to 9 to the 3x plus 8. So one is a base of 27, the other is a base of 9. Can either of these be rewritten as the power of the other one?
What?
No, but could you use 3?
Correct. So I always look first to say, obviously, to change as little as possible, right? But 9 squared or something like that obviously isn't 27, so that means I'm going to have to change both of them. So, as Addie pointed out, 3 is what we'll use. So, this is going to be 3 cubed, and then we have the times the 4x minus 1 is equal to, over here, 3 squared times 3x plus 8. Now I have the same base, so their powers are equal to each other. I'm going to go ahead and distribute here. So I've got 12x minus 3 is equal to 6x plus 16. Subtract 6x, add 3. So I'm going to have 6x is equal to 19. Divide by 6. X is equal to 19 over 6. Obviously, if we can reduce, we should always do that. But that one doesn't, so we'll just leave it there. Ten to the 3x minus 10, there's like 10 in this problem apparently, equals 1 over 100, and that whole thing raised to the 6x minus 1.
Wow.
Any ideas for this one, what I can do?
10 would be -2.
Yep, so the 1 over 100, that would be like 1 over 10 squared. So if we want to flip it, then it would be 10 to the -2. So this is going to become 10 to the 3x minus 10 is equal to 10 to the -2 times the 6x minus 1. Set the powers equal to each other. 3x minus 10 is equal to -12x plus 2. Move things around. I'm going to add the 12x and add 10. So I've got 15x is equal to 12. Divide by 15. So when I reduce, that's going to be equal to 4/5. Questions about the exponential ones?
No.
Um, 12. 8 to the x is equal to 20. So this is where we're going to be using the stuff that we, what was that, 2 sections ago now, in 7-4, when I showed you the E and the L. We use the E if it's a log and we're making it exponential. I'm going to use the L if it's exponential and I'm making it a log, because I don't know what power to raise 8 to equal 20, right? I know it's not squared. I know it's not 1. Somewhere in between that value, right?
So it has to be decimal or like fraction.
Decimal.
Decimal.
So we're going to use the L. So we come down through the 8, over through the 20, and back up to the X. So this says log base 8 of 20 is equal to X. And then you can either use log base. You can use the change of base formula if you want to do it that way. If you do that, it would be log 20 over log 8. So just as a reminder to get log base in case you've forgotten,
Great.
you hit math and then arrow up, and option A, it's what it's around where it should be. It should say log base, and it's like, looks like it's screaming at you.
I hit everyone but the math. I hit second alpha. I just.
What'd you say it is, Jonah?
1.44.
1.44.
I did get that. Yep. Ready? Thanks.
16. 7 to the 6x is equal to 12.
Oh, I wrote 20.
So it's exponential, meaning I need to use a log to solve. So we come down through the 7, over through 12, and back to 6x. So I've got log base 7 of 12 equals 6x. You can either just type this in, or you can go ahead and say log base 7 of 12 all divided by 6. Cooper, probably because of the way you need to type it in, I would do your find the log first and then hit divide by 6. No, because it's an exponential, so I have to use a log to solve it. If it started this way, then yes, I could have.
22 more.
Like if it starts as a log, you use an exponential to solve it. If it starts as exponential, you use a log to solve it. One more of this kind. Number 18. 10 to the 3x. We're looking plus sign. Let me fix that. Plus 4 equals 9. What do I do with this one?
Subtract 4.
Yep, I have to get it basically where it's just the number raised to a power on the one side and then everything else on the other side for me to be able to do my log to solve. So I've got 10 to the 3x is equal to 5. I should have hit solve to see what it was going to do to solve 10 to the 3x. I don't know. I'm just intrigued to know. All right, so we use log, come down through 10, back up and around. So we've got log base 10, which is also what?
Just normal log.
It's just the common log, so I don't even have to write it. You can if you want to, of 5. So you don't have to use log base. You can just hit log 5 is equal to 3x, and then just divide by 3.
Oh, 2, 3.
Any questions on those?
No.
Not particularly.
All right, now we're getting into actually solving the logarithmic equations. Now, if you remember, I think it was 2 days ago when we were doing problems, I told you that inside of a log, we can't have what?
A negative.
Can't have a negative. So, these are problems where we have to check for an extraneous solution, okay? Because a value may come up to be a solution of the inside, but if it's negative, it can't be in the log, okay? So we're going to have to plug in, and a lot of times I just do it by a quick glance. I'll probably write out like one of them or something, 1 or 2 of them, but just be aware of that, is that you do need to watch for those. And it says it in the instructions, but. 24, log base 5 of 5x plus 9 is equal to log base 5 of 6x. All right, so both of these are log base 5. So that means that I take what's inside of each of them and set it equal to each other. That's why we can end up with extraneous solutions, because what's inside may not work in the actual log itself. So that's why we have to be careful of that. So I've got 5x plus 9 is equal to 6x. Subtract 5x. And so I would just get 9 is equal to x. I'm just going to do a quick glance. It's not necessarily just that this number is negative. It's when I plug it in. Well, plugging that in, that whole thing stays positive. Over here, it stays positive. So this is my only answer, and it does work. Uh, 28. Log of 12x minus 11 equals log of 3x plus 13. So So these are both common logs. So again, take what's inside, set it equal to each other. So 12x minus 11 equals 3x plus 13. I'm going to subtract 3x, add 11. So I've got 9x is equal to 24. Divide by 9. So x is equal to 8/3. Just doing a quick glance here, 8/3. I've got 12 divided by 3 is 4. 4 times 8 is 32. Subtract 11. Still positive over here. Everything would be positive, so I know I'm good there. I'm mostly checking if there's anything being subtracted or if this number is negative. If everything's being added or this number is positive, you should be good. So 30 log base 6 of 3x minus 10 equals log base 6 of 14 minus 5x. So both are log base 6. So I've got 3x minus 10 equals 14 minus 5x.
What happens if the log base isn't the same?
Then you can't do it this way.
Okay.
They shouldn't be giving you any like that in this stuff.
Yeah.
So if I plug in 3, then I've got 9 minus 10, that's negative 1. And then if I plug in 3 over here, I've got 14 minus 15, that's also negative 1. So this is extraneous. Or you can write, the other option, the way the book's going to write the answer when that happens is they're just going to write no solution. So you can either just write x equals 3 and then write that it's extraneous, or you can write no solution and that's fine as well. Does that make sense? Questions about those? All right, I think the last type here is actually, not that that's not solving log equations, but using like the E method to solve 32. Log base 4 of x is equal to negative 1. So I'm solving for x. I have a log. That means I'm going to use an exponential to solve it. We start down here at 4. We loop around and make the E, or the curly Q. So I've got 4 to the negative 1 equals x. So 1/4 equals x.
How do we? Never mind.
No, I want to know.
How do we know when to use the E or the L? Or do we use the L when we do the log? I mean, when we don't
If you
the
have an
log?
exponential equation and you're solving for the variable in the exponent, you're going to use a log.
Okay.
If
So-
you have a log, like this one, and you're solving for this value in here,
That's what I thought. That's why.
yeah. I mean, hypothetically, I guess they could give you this to solve for, but it's almost always going to be this value right here that you're solving for. And so you use the E to solve it. So if you start with a log, you have to undo it with an exponential. If you start with an exponential, you undo it with a log.
That's what I was.
It's just always the opposite of what you see.
Okay. That's what I was thinking. Just so we didn't ask me.
I just want to know.
I don't really remember what I did.
34. 1/3 times the log of 5 of, wow, hold on. Let me start that over. 1/3 log base 5 of 12x equals 2.
Do we put the 1/3 to the X?
So it would technically go on both things. And I can do it that way. But I can also, because I'm solving, it's not going to matter. But it will make your life easier if you don't write it to the 1/3, because then you have a cube root. And instead, I'm just going to multiply both sides by 3.
Okay.
So yes, with what we were doing yesterday, that would have been what you would have done. You would have stuck it up as the exponent. But I'm going to multiply both sides by 3 instead. So I'm going to end up with log base 5 of 12x is equal to 6. Now,
Never mind.
what?
I was thinking, does the 3 not go to like each number, or we just?
Well, I'm just doing it by both sides.
Like, would you not?
Like if I had 1/3 x equals 2, I would just multiply,
Okay.
so then it would just be x equals 6.
Okay.
You're thinking about too much.
I was thinking, like, would you multiply like the 12x in base?
If I rewrote it the way that we were doing the stuff yesterday, this would have become log base 5 of 12x all to the 1/3, or log base 5 of the cube root of 12x. Which is just going to make it a little bit more, like, mathematically complicated if I do it that way. That's why I did it this way instead.
You can do it the easy way.
So I've got, using an exponential to solve, 5 to the 6 is equal to 12x. I would most certainly use a calculator to do this.
15, 6, 2,
And then just divide it by 12. You can either leave it as a fraction or you can write it as the decimal.
1,302.08.
So any of those would be sufficient there. 38. We just have 2 more.
I got plenty.
Log base 4 of negative x plus log base 4 of x plus 10 is equal to 2.
Might not have plenty space.
It's not as bad as it looks. All right, so what do we notice is different about this one compared to the last one?
There's 2 plus logs.
There's 2 logs being added together, and they're all on the same side, right?
Yes.
Yes.
What do you also notice about those logs?
They have the same base.
They have the same base. I'm assuming you're about to say that this is negative. We don't know what the number is. X might be a negative number, so then it cancels out, so it might be fine. Might end up being extraneous. We don't know yet. Find out in a minute.
I was going to say, because if you're adding them, both the x's cancel each other.
Yeah.
So we are adding, but this isn't really adding. This is the stuff we did yesterday. The log of the product is equal to the sum of the logs. So I have logs being added together. That means that the stuff inside of them gets multiplied. So this is going to become 1 log base 4 of negative x times x plus 10. I'm going to just put that all in there so it doesn't get confusing. Equals 2. If you want, you could have gone ahead and distributed that. I'm just going to do it in the next step. So I have a log. I'm still using an exponential to solve. We start down here. 4 squared is equal to everything that's inside the log. So 4 squared, if you wanted to go ahead and write that as 16, you could. I'm going to distribute this negative x, so negative x squared minus 10x. I need to get this all to one side. So I'm going to say 0 is equal to, actually, hold on. I'm going to make our life easier. I'm going to move the negatives to the left because then I have everything is positive. You cool with that?
I'm great with that.
Normally I move 1 instead of 2, but if they're both negative, I'm going to move them over. So I've got x squared plus 10x plus 16 equals 0. And now we get to do our favorite thing in the whole world and factor.
Ow.
So I need factors of 16 that add up to 10, 8 and 2. So this is x plus 8, x plus 2 equals 0. Set each piece equal to 0 and solve. X plus 8 equals 0, x plus 2 equals 0. So x equals negative 8 and x equals negative 2. Now, why did I try an equal sign there? Not necessarily, because remember,
You have to plug it
negative x, it was here. So negative times a negative is positive, so both numbers are okay over here. Negative 8 plus 10, well, that's a positive number. Negative 2 plus 10 is a positive number, so these both do, in fact, work. But I always want to check because obviously it can happen where they don't. Last one. 40. 4 ln of negative x plus 3 equals 21.
Could we subtract like 3?
Yep, I would subtract 3 first. So I've got 4 ln of negative x is equal to 18. Divide by 4. Ln of negative x is equal to 9 over 2. And then I'm going to start here. Obviously the base isn't written, but there's an e there, imaginary. So I've got e to the 9 halves is equal to negative x. Divide by negative. So I have negative e to the 9 halves. And somebody can tell me what e to the 9 halves is.
Negative 90. Yeah. 102.
All right, now, if you left it as far as e goes, I would take it. But again, I want to just do a quick check back. It was a negative x, so negative times negative is positive, so I'm good.
Great. Filled up my page
Great.
perfectly.
Any questions about this stuff?
No. 4.
5, hold on, 7, 11, 15, 17, 21, 27, 29, 35, 41.
Oh, I didn't finish writing my name. I just had to add